Hello CFA friends. In this reading of derivatives we will talk about forward markets and contracts. So let's get started. Okay, we're going to start with a foundational concept, the idea of no arbitrage principle. So the idea that we need to find a way to price these forwards or futures contracts in a way that would not permit any riskless arbitrage that can be exploited by potentially arbitrageurs out there. So the idea is that we will try to come up with a formula that will result in zero value at initiation for these contracts. And of course, because the formulae for futures will be very similar to the formula of forwards, we'll basically be able to cover essentially two concepts at once. Right, let's have a look first of all at the very basic cost of carry formula. So you can see it here on the slide. The idea is that to price the forward contract in a no arbitrage way, we will take the spot price as zero here and we'll compound it at the cost of borrowing essentially. As a proxy for that we use the risk-free rate and we compound this to the maturity of the contract. Now, why do we do this? Why does the cost of borrowing matter when pricing forward contracts? And to understand this, maybe we should think about what happens when we actually buy a physical asset. So let's say I were to buy a barrel of oil for $80 today, and I intend to hold it, let's say, for 6 months. Well, of course, that would involve a cash outlay, immediate cash outlay today, and of course the opportunity cost of that cash outlay would be the maybe the interest income that I would have earned in a savings account, i.e. the risk-free rate. Whereas if I go for a forward contract, then I don't have to have this initial cash outlay. All I do is I simply commit to pay a certain dollar amount in the future. So that is our basic cost of carry formula, i.e. without adding any bells and whistles. A little bit later down the road we will see how, for example, dividends or coupons, i.e. benefits of carry, will affect this formula as well. Okay, moving on. So here's a more concrete example of what we're talking about. Let's, for example, take a 6-month forward on a zero coupon bond. Right, the bond is currently selling at $600 and its face value is $1,000. So the idea basically is that this is a deep discount instrument which we are currently able to purchase at $600. The current risk-free rate is 3%. So what should be the no arbitrage forward price for a forward contract that allows me to buy that zero coupon bond 6 months from today? We are going to apply the basic cost of carry formula, which we've seen on the previous slide. So this is what we get. We get the spot price of $600 compounded the risk-free rate of 3% for 6 out of 12 months, which of course is a power. On our business analyst too, we'll be using the Y to the little X button. So as you can see, the no arbitrage price here will be 608.93, which of course is necessarily higher than the spot price because we have increased it by the cost of borrowing. Now, in order to prove that this has to be the right price, we will carry out 2 thought experiments. We'll basically pretend, in the first experiment, we'll pretend that the actual price, the actual market price of the forward was actually higher than 608, and in the second experiment, we'll pretend the price was lower than 608. In both cases, we'll demonstrate that if the price deviates from 608, we'll then have an arbitrage opportunity. So let's have a look at this. Okay, suppose initially the price is 610. So in other words, we're talking about a price which is too high. So why would that give us riskless arbitrage? Yes, the problem is as follows. The market price of the forward, in our case, is higher than the no arbitrage price of the forward. So what's the idea here? The idea is that I can sell the forward, or short the forward if you prefer the more technical term, and because this involves arbitrage, in an arbitrage transaction we'll have both a long as well as a short side to it. We will have to buy the spot, and buying the spot essentially means that I will be buying the bond today physically. Selling the forward or shorting the forward would mean that I'm promising to deliver that zero coupon bond to somebody else at $610 6 months down the road. Okay. Now, secondly, if I'm going to buy that bond today physically, remember, arbitrageurs, or more simply arbors, if you allow me to use that simpler word, arbors are assumed to start with zero capital. So for them to buy this bond, they need to obviously borrow the money. So the next step, or one of the steps, they don't have to necessarily go in this order, but one of the steps is to borrow at the risk-free rate. And of course, again, here you might challenge us by saying, are people and arbors able to borrow at the risk-free rate? And they probably aren't, but this is a simplifying assumption of these models. Now we can borrow and lend at the risk-free rate. So we're going to borrow the money, the $600 at the risk-free rate, to be able to buy that bond today. Another step that we'll need is we'll need to carry the spot, i.e. carry the bond, between now and maturity of the forward contract. And finally, we need to deliver the spot through the overvalued forward. And this last step, I'm going to use an exclamation mark here to show you that this is this last step that will actually create the arbitrage profit. Because essentially, we are delivering a bond through an overvalued forward. Remember what we started out with. The market price of the forward was overvalued compared to the no arbitrage price. Remember, the no arbitrage price is determined by the basic formula S0 compounded by 1 plus risk-free rate to the power of T, which is the time to maturity. And that is what allows us to get this arbitrage profit. Now, guess what we're going to call this type of transaction? This is a very well-known arbitrage transaction in finance. And a hint to what it's going to be called is this word here. The transaction's name is cash and carry. So this is cash and carry arbitrage. Remember, when do we get a cash and carry arbitrage? We get it when the market price of the forward exceeds the no arbitrage price of the forward. Okay, great. So now let's look at this conceptual example in practice with the numbers. Okay, so there you go. These are the numbers. And remember, the steps can go in any way, really. So typically, the arbor will start by borrowing money. So they'll have to borrow $600. And we assume that they are able to borrow that at the risk-free rate of 3%. And of course, they would want to repay this 180 days down the road. Of course, our cost of carry formula tells us that the future value of this loan will be 608.93. Now, once we've got the $600, we're actually going to go and buy the bond. Remember, the bond represents our spot price at time zero. And because we bought the bond, we need to carry out the offsetting arbitrage transaction, which will be shorting the overvalued forward. Remember that our forward is overvalued at 610, should have been 608. And now we just have to carry the bond and wait until maturity. Now at maturity, we have to now deliver the bond and receive the famous $610. And of course our loan matures and we owe the bank $608.93, of course, which was the 600 borrowed at 3% for 180 days. Now that leaves us with some arbitrage profit of 1.07, which is the difference, of course, between the receipts of 610 and the repayment of the loan of 608.93. Now that's not a lot of money, but of course this was only based on an investment of $600. Of course, find bigger investment opportunities and your arbitrage profit increases. Not only that, but arbitrage by definition is meant, I can't say it's always, but it's meant to be riskless. Excellent. Now let's have a look at the other side of the coin, which would be a situation where the market price of the forward is actually lower than 608. So this time we are below the no arbitrage price. So let's say the market price of the forward is now 595. And of course this again has to allow us riskless arbitrage. But this time, instead of employing a cash and carry strategy, we will employ the reverse logic of the cash and carry strategy, which of course, not surprisingly, is called reverse cash and carry. So let's again have a look conceptually at the strategy. Okay. Now, first of all, what we know about the reverse cash and carry is that the market price of the forward is actually too low, so it's actually lower than the no arbitrage price of the forward. A market price of the forward of $595 is less than the no arbitrage price of the forward, which was 608, right? 608. So what is the strategy? What should the strategy be in this case? Well, of course, if you've got an undervalued instrument, doesn't matter what instrument that is, but you gotta buy or long that instrument. So in this case, we have one of the steps has to be long the undervalued forward. And because it is an arbitrage transaction, you must have a short side to the long position. The short side will be short sell the spot. Short sell the spot. Now what does that mean? It's not just selling the spot, short selling the spot. So short selling the spot means that we need to borrow the famous $600 zero coupon bond, which we currently do not own, and then sell it in the open marketplace to generate $600 today. Now, of course, if you end up holding $600 today, you need to find something to do with the dollars. And what we're going to do is we're going to invest the dollars at the risk-free rate for the 180 days at this point. Okay, now what happens 6 months down the road? Let's think about what's the situation now. You've got this savings account that generated some money, fair enough, but you've also short sold a physical asset. So at some point in the future, you need to cover your short position. So what we're going to do now is we're going to use the proceeds from our savings account to buy the spot, buy the bond back in the marketplace and cover our short position. Okay, that's the idea. And hopefully, because at this point here, we went long via an undervalued forward contract, that step will now ensure that after closing all our positions, we shall be left with a little bit of profit. And that idea is the idea of reverse cash and carry. Okay, but that's conceptually. Let's put some numbers to the concept. Okay, so today, as we agreed, we will short sell the bond, therefore receive $600. We'll take the $600, invest those proceeds at the risk-free rate. Again, this is our risk-free rate for 180 days, and this will generate 608 spot $93 in the future. Again, today we will have to go long the forward, which we agreed was undervalued at 595 as well. So essentially we now say that in the future we would like to buy that bond, and the purpose of that longing the forward is to ensure that we are able to cover our short position at 595. Now in 6 months, of course, your savings account will pay you $608. You'll be able to buy the bond at 595. The difference of 1393 will be your arbitrage profit. Fantastic. Okay, so basically those two examples, hopefully guys, have convinced you that the famous cost of carry formula, i.e. forward is S1 plus RFT, that formula actually works. So this is not just some theoretical relationship, this is actually meant to hold as we speak, because various traders, banks will be engaging in either cash and carry or reverse cash and carry to ensure that that formula works, to pick up any minor arbitrage profit that may be out there. Okay, now we're moving on to the valuation. So this first bit, this formula I've just been showing you, is the pricing formula. Now when we're talking about forwards, futures, even swaps later on, we have to be very careful with a couple of words. We've got pricing and we've got valuing. Now they do sound, I mean, if you're not careful, they do sound like they're synonymous. Pricing, valuing, looks like it's the same thing. They cannot be more different. Okay, they cannot be more different. Pricing is discovering the initial price of a forward contract or derivative instrument that will prevent arbitrage. Okay, so pricing is the idea that we want a zero value at initiation. We don't want any party having to pay money up front in a forward contract, right? Valuing a forward contract is the idea that after initiation, say maybe 5, 10, 15 days pass after I've entered into a contract, I now want to know what the value of this contract is, so I need to value that contract. Okay, and of course, we need to be familiar with our key words here. Long is the person, the party who's promised to buy in the future, so they're bullish. They're expecting the asset to appreciate, and indeed they make profits if the asset appreciates. Short, on the other hand, is the opposite idea. It's the party who's betting on the asset declining, and they make profits in bear markets. Right, now why would you want to value a forward contract? Okay, so we understood pricing, very important, but why would you want to value it? Well, first of all, remember, and you spend a lot of time studying accounting for the CFA program, and you probably know by now that derivatives have to be reported at fair value in your financial statements. So one reason is a purely accounting reason. At the end of the year, I need to show the value of my derivatives on the books in terms of their fair value, market price, essentially. So this is the idea of marking to market our instruments. The second reason may be to manage our credit risk. So to see what my credit exposure is to various counterparties that I have trading with. So as you know, if we've got a winner and a loser in a transaction, the loser owes some money to the winner. We want to know how much money that is. And of course, valuing the derivative instrument there will allow us to manage our credit risk. Number 3, we're looking at a payment necessary to terminate the derivative. So I could have entered into a 90-day contract, but I'm now tired of playing this game. Maybe it's 40 days into the contract. I want to exit the contract, so I just basically pick up the phone and say, okay, how much do I owe you to close these positions today? Number 4, parties agree to mark to market. I think it's kind of related to the first idea of marking to market your derivatives on the financial statements, but here the idea is that we want to again mitigate credit risk. The kind of theoretical idea is that when you enter into a forward contract, there is no periodic marking to market. The payments are only made at expiry. That's at least what the books will tell you. But in practice, following especially the credit crisis and all the debacles coming out of it, we have now decided often to meet periodically and mark to market our derivatives. So the idea is that we don't want too much exposure to build between the time we enter those derivative instruments and the time we have to exit them at maturity. So we will meet periodically, we value them, and the loser pays a certain amount to the winner. Now, okay, let's move to the nitty-gritty of the actual valuation of these things. And please remember, they're different formulae, they're different concepts. Most importantly, in a numerical scenario, they are going to be completely different formulae. Also, one tip before we start, there's no need to learn one set of formulae for long and one set of formulae for short. Remember, derivatives trading is nothing but a zero-sum game. So if someone made money, then it means $10. It means someone across the world, somewhere else, has lost money in the same amount. So basically, all we got to do is take the position of, or the perspective of the long player. And in the event that an exam question asks for the profit to short, by the way, these are very important buzzwords to underline in an exam question. If the question is asking for short, simply put a minus sign to the answer that comes from the long formula. So, from the point of view of the long player, at a valuation date, let's call that small t, remember the long player is due to receive the physical asset at some point in the future. Well, what's the best guess of what that asset will be worth at maturity? Well, the best guess is the current spot price. So we're going to pretend that the long player is due to receive the current value of the underlying asset. Now, on the other side, that player also needs to make a payment. And we have agreed that this payment has to be the forward price that we calculated with our no arbitrage formula. And just to be clear, what is that formula once again? The formula that determined the forward price was S1 plus RF to the power of T. So that's where the formulae link, if you want, but the completely different formula, as you can see. So that formula simply discovers the forward price that you owe at maturity. Now remember, we're not at maturity at the moment, so what we're going to do is going to present value that forward price between the maturity date and the valuation date. In a minute I'll be showing you some timelines, so it will become a little bit clearer. And remember, if you are asked to value the short position, simply stick a negative sign in front of the answer from the long formula. Okay, a couple of facts about forward contracts and their values. The value of a forward contract at time zero is always $0, i.e. the idea is that I'm given a piece of paper to sign either from the point of view of long or short, but I don't have to make any upfront payment. Okay, and that's because I use the famous cost of carry model, which ensured that there was no arbitrage and no value at initiation. Now, also, at maturity, it's very easy to know the value of the contract. Say, remember, if I go back to the example of the barrel of oil, let's say I committed to buy a barrel of oil at $80 in 6 months. Let's say in 6 months the price of physical oil is $88. Well, I'm in luck because I pay $80 to immediately receive something worth $88. So I've got an $8 profit. So in other words, at maturity, the value of your contract is simply the difference between the spot price at maturity and the initially agreed forward price. Or if you prefer to relate that to our formula from before, you could still take that forward price and discount it at 1 plus RF to the time to maturity, where at maturity there's 0 time to maturity. So essentially this ends up being simply the forward price. Now the value of a long position prior to maturity is simply the present value of the spot that we believe we'll have at maturity minus the present value of the forward price. So what do we exactly mean with the present value of the spot? Well, of course, there's time value of money. Of course, we'll still need to discount at the risk-free rate, but there are other things that we will have to take into consideration when computing the present value of the spot. And these are namely things like dividends and coupons. And these are essentially examples of benefits of carry. Much like risk-free rate was a cost of carry, dividends and coupons that you get on that underlying asset will be considered benefits of carry. In fact, these benefits of carry will tend to reduce the forward price, but we will see this a little bit later. Right, let's go to a more concrete example, and just prior to that, to summarize what the formula will look like. So we are taking the spot price at the valuation date, and we are subtracting the present value of the forward price at that point in time. Now this is the formula. I would probably suggest to focus on the conceptual meaning of this formula. I would probably suggest learn the formula as words as opposed to a lot of notation, capital T, small t, RFST. Learn it as a concept, because if you learn it as a concept, you'll actually realize that, you know what, all forward and futures formulae obey that concept, which is nice, isn't it? Because you can then go to a completely different forward contract, maybe on bonds or basket of equities, and that formula will still work as far as the valuation is concerned. So it's spot price minus present value of forward price. In a little while we'll also involve dividends and coupons on bonds. Okay, but let's look at an example of a valuation, and this of course carries on from our previous cost of carry model on the zero coupon bond. So now what's happened? 2 months have passed and the spot price has gone up to $615. Risk-free rate is still 3%. Now, before I dive into the computation, the very first thing I tend to do is I tend to prepare myself a timeline so I kind of know where I stand on the timeline. So just to remember, the original case, you entered into a contract at time 0. This contract was meant to expire at time 6, and we are currently at time 2. So let's call that the valuation date. Okay, the valuation date. And at this valuation date, the price of our bond is $615. Whereas if you go back through the slides, the originally agreed forward price on expiry was 608.93. Okay, so what are we going to be doing here? Well, as far as the value of the spot's concerned, we'll be using 615, no doubt about that. But we will need to present value the forward price back to the valuation date, back to month 2. It's going to take that pot of money and bring it back to time 2, i.e. that is discounting that amount of money back at 3% for 4 months. Okay, so let's see this in practice through our slides. Okay, so notice now that we are on day 60, i.e. 2 months down the road, and notice that we're going to be following our plain vanilla formula from the perspective of the long player. So at time 2, the bond is worth 615, that's our S small t, and the forward price at maturity would have been 608.93, which we're now discounting at the risk-free rate, but notice we are using 4 months, not 6 months. And of course, to understand that, all you got to do is just go back and look at the timeline. So that's why I suggest timelines are very important. If you don't spend an extra half a minute on a timeline, then there's a higher risk that you may get your timings wrong, basically. And look, the profit is $12. And here's one tip I'm going to give you. When you first study this topic, it's very easy to confuse the two formulas because you've got one formula for pricing and a completely different formula for valuation. Well, here's a quick tip, especially for people making their baby steps in this topic area. If after computing this, you come up with a number that was around 600, well then, is that the value of the contract at the end of 2 months? No, it's not. You probably got confused and you used the pricing formula because you would have started with 600, you would have done something to that number. The valuation basically should capture the difference in the spot price. So remember what happened. We started at $600 and at the end of 2 months we were at $615. Right? So essentially our profit or our P&L, profit and loss, on this position is not going to be miles away from $15. Indeed, it is $12. Right? So this is one sanity check when you're doing these computations to make sure, did I actually use the right formula when I was valuing this? And of course, if they asked you for the short player, well, if the long player is having a party because they earn $12, then someone across the globe is very sad because they lost $12. Okay. Now, pricing equity forward contracts. So basically what we're going to do here is we're going to move from the zero coupon bond to a share of equity. And of course, you know what happens with equity. They will typically pay dividends. And of course, if it was a bond, which is a little bit later, then they'll be paying coupons. But the point being that dividends and coupons represent benefit of carry, much like the risk-free rate or the cost. I prefer to say cost of borrowing rather than risk-free rate. So cost of borrowing represents a cost of carry because it takes money away from your position. Well, dividends and coupons will be benefits of carry because they are paid to the owner of the physical asset. Okay, great. So logically, if I had a cost of carry that will force the forward price to increase. That's what we demonstrated via the basic formula. Then logically, a benefit of carry should cause the forward price to decline. And ultimately, it's going to be all about the balance between costs and benefits of carry. A little bit later in another reading, we will mention two very, very key words, contango and backwardation. And you know what? Contango and backwardation will be determined by whether costs exceed benefits or vice versa. But more on that later. Okay. Now, let's have a look at how we price the equity forward first of all. Remember, we are back to the pricing formula. So for each of these concepts, we will look at two sets of formulae, pricing formula and valuation. So we're back to the pricing formula. But now we're going to add that additional accessory in the form of a dividend. So before I tackle this formula, let me just give you some background to this. So suppose I've got time 0 where I enter into a contract, and suppose that contract matures at time 90. So that's my maturity. And let's say I've got a dividend on day 60. Now, what do I need to do here? Can I ignore that dividend first of all? And the issue with this dividend is that on day 0, you basically promised to buy a share of equity 3 months from today. Now, what's this dividend going to do to your derivative position? Well, the dividend will be paid to the owner of the equity. It won't be paid to the owner of the derivative. So from the perspective of the derivative holder, this is money that is lost, essentially, because it leaves the company before the derivative holder gets to buy the equity. So what are we going to do with this dividend? Well, first of all, we will discount the dividend back to time 0 at the risk-free rate. And so we're going to take the spot at time 0 minus the present value of the dividend. So think of this as I tend to call this the net spot amount, i.e. net of the dividend. And once I've got this pot of money, I will then compound that, and this is at the risk-free rate, and this is also at the risk-free rate. We're going to compound that net spot amount to maturity in order to be able to compute the forward price. Okay, and essentially with this first picture, we're going to explain the first formula on the slide. So let's actually go back and see what that formula says. Okay, well, we're basically explaining this formula. We're taking the spot, reducing it by the present value of the dividend at time 0, and then compounding the whole lot at the risk-free rate to maturity. And that's absolutely fine. Now, mathematically equivalent is the second formula. You could have taken the spot directly, compounded it to maturity, and then you could have also taken the dividend from day 60, compound that to day 90, and then do the subtraction at that point in time. So because they're mathematically equivalent, you don't have to learn both formulae. I would say just choose which one you prefer and stick to it for exam day. Okay, now moving on to the valuation. Let's look at this valuation. Well, is this really different from the basic valuation of the zero coupon bond? And what you will discover is that cosmetically it might look a little bit more complex, but if you translate this to words, it should still say the same thing. So this initial thing should still say, this is essentially my net spot amount, net of the dividend, at the time of valuation, right? This bit here. And this bit here is nothing but the present value of the forward price at the time of valuation. And again, we've got a formula here that values the position from the perspective of the long player. So if you, for example, just to continue with our conceptual example, if we had moved, for example, from day 0 to day 10, and this is now our valuation date, what should happen? Well, first I will need to take that dividend and present value it back to the valuation date, i.e. present value it for 50 days, from day 60 back to day 10. And the other thing that will need to happen is I'll need to take the forward price, which is of course determined by the cost of carry formula, and discount that as well to the valuation date for 80 days, from day 90 to day 10. Once I've done all that, I simply have to apply my valuation formula. Okay, now equity indices. Now this is going to be slightly different cosmetically, because what is an equity index? Let's take, for example, the S&P 500 or the FTSE 100. Well, this is a collection of many stocks. So you can't quite say, well, the S&P 500 is going to pay me a dividend in 60 days, because there are lots of stocks paying dividends at different times. So academics will tend to view this as paying not a discrete dividend at a particular point in time, but I'll view it as something paying a continuous dividend. And of course, when you come across the word continuously compounding rates, first thing that will come to mind is the magic number E and its inverse operator, the natural logarithm, which we're sort of vaguely familiar with from level 1. But again, the formulae may look different because they've got this E number in them, but in practice they will be doing exactly the same job. So let's see what that is. Okay, so in this first formula, okay, and again, the first reaction is this is nothing like what we've studied so far. But this is exactly the same formula, because what are we doing here? We are taking the spot price at time 0. Remember, we're back to pricing now, so discarding the no arbitrage price at time 0. We're taking the spot at time 0. We need to increase this by the cost of borrowing. There you go, that's your cost of borrowing, but it is continuously compounded risk-free rate in this case. And then we have to reduce it by the benefit of carry, which is this delta here. The continuously compounded dividend yield is given this delta letter here. So this again is essentially your net cost of carry. I will just multiply by the time to maturity. This is essentially the formula. Now you can rearrange it in other ways, but essentially it's not going to change the basic concept. The basic concept is this: when you're pricing a forward contract, the costs of carry will cause the forward price to rise, so we're going to be adding them, and the benefits of carry, such as the dividend yield, will cause the forward price to fall, so we'll be subtracting them, essentially. So this is the formula as far as equity indices is concerned. Now, how are we going to value the equity index? And again, you can see a formula that looks pretty ugly, right? Pretty ugly. But is this really any different? Is this really any different from the other valuation formula? Well, what are we doing in the first part of the formula? Again, we're taking the long perspective as always. So long needs to receive this equity index in the future. So what is my guess for the equity index value? It's the value at the valuation date, which is ST. Now, of course, that equity index will keep paying the continuous dividend. Now remember, whoever holds the derivative does not get the dividend. The dividend goes to the shareholders. Okay? So from the perspective of the derivative holder, that dividend is actually lost, and therefore will have to be subtracted from the futures price, the forward price. Now you can't subtract a continuously compounded dividend because it's not paid, let's say, on day 60. You can't just take, okay, that's a $2 dividend, let me just subtract it. Can't do that because it's continuous, it's actually a yield. So what we're going to do is we're going to divide the spot by the continuous dividend. Essentially, that has the same effect of reducing the spot price. So again, this will be the net spot price at the valuation date. Whereas the second bit of the formula is nothing but the forward price that we agreed to pay at maturity. And remember, how did we determine that? It was S0 times E to the power of RFC minus delta C times T. That's the formula from the prior slide, the pricing formula. So that's what we use to discover what the forward price should be, but we're now not using that formula, we're now valuing. So what we're going to do is going to take the forward price and discount it at the risk-free rate from maturity to the valuation date. So that is essentially your present value of the forward price yet again. So notice, guys, how in all this formulae, this concept remains the same. So that's why I'm telling you, focus on the wordy concept and not so much on the mathematical notation behind this formula. Yes, the mathematical notation may differ here and there, especially in equity indices where you got continuous compounding, but the concept is exactly the same. So you should really, just knowing a couple of concepts, pricing, valuation, you should actually go ahead and get a lot of valuable points from the forward reading. Okay, so let's have a look at the bond forwards. And of course we started with a bond forward on zero coupon bonds. We're just going to sophisticate it a little bit. We're now going to have, instead of a T-bill, which pays no coupons, we're going to have a T-bond, maybe that pays coupons. So these coupons, much like the dividend on equities, represent a benefit of carry. So essentially these cash flows offset the cost of carry and therefore reduce the futures price. As you can appreciate, it's exactly the same story that I told you in the equity forwards. Simply the formula will look exactly the same, but instead of having a present value of a dividend in the formula, we'll now replace it with a present value of a coupon. Okay, so there you go. I'm not going to be spending too much time on this slide at this point because it's essentially going to tell you exactly the same story. But look, say you've decided to learn that formula. Again, the two formulae here are mathematically equivalent. Say you decided to learn the first formula. Well, what is the pricing formula then doing? It's taking the spot price of your treasury bond at time 0. Then it's looking at any coupons that may occur between time 0 and maturity, present valuing those coupons, subtracting them from the spot, i.e. computing your net spot price at time 0, and then compounding the lot to maturity at the risk-free rate. So that's as far as pricing is concerned. What about the valuation? Well, again, the valuation formula is exactly the same. At a point in the future, we've got the net spot, and this is simply the spot at that point in time net of the coupon, the present value of the coupon, and then we are subtracting the present value of the forward price. Now, I'm not going to lie to you, it's probably forward rate agreement, so what's coming now is probably going to be the most challenging learning outcome in this particular reading. Okay, so this is the kind of big dog we'll be talking about here. So make sure you do set aside a little bit of time to try and understand this. It is the odd one out. It works slightly differently. So let me start by some very basic kind of warm-up knowledge. So in terms of a forward rate agreement, we got a long player and we got a short player, right? Long and short. So you got to learn this. This is the foundational knowledge. Long is due to receive LIBOR in the future. So because LIBOR is an uncertain number, right? We don't know what LIBOR will be in the future. That will be a wavy line, okay? Uncertain variable in the future. So that's the underlying, basically, that we don't know the value of. In exchange for that, long will make a fixed payment to short, okay? And the fixed payment is basically, if you want, the price of that forward rate agreement in percentage terms. So this could be, let's say, 5%, and that is fixed from the start. So now, what does that mean? Who is this long player and who is this short player? So long has committed to receive a variable rate and pay a fixed rate. So long must be expecting for rates to rise, for LIBORs to rise. And that's what's going to cause them to make profits. Short, on the other hand, is bearish on rates. Short believes rates will decline, and therefore he's entered into a position to receive a fixed rate of 5, and he'll benefit when rates decline, hopefully below 5. Now, there are other wordy questions you could get, potentially. Okay, for example, you could think of long as someone who is committing to borrow at a fixed rate of 5%. Would you agree? If you promise to borrow at 5% in the future, then that picture will apply to you, because essentially you will be paying 5%. Similarly, short is committing to lend at 5% in the future. And of course, these transactions come with what's known as notional principal. Okay, they always come with this notional principal. Let's say, for the sake of argument, our notional principal is $1 million. And before we move on, I need to tell you this. This principal is not received in anyone's bank account. So don't think that once I sign this paper, I open my bank account and say, ooh, 1 million's coming. It's not going to work like that, because if you think about it, long is borrowing 1 million, but then at the same time is also lending 1 million to short. So this 1 million is exactly what it says on the tin. It is a notional amount, so it's purely there for computational purposes, nothing more than that. So we're just using it to multiply by the 5% and by the LIBOR. So this is the basic knowledge that I want you to have behind the forward rate agreements before we get started. We also want you to know that this particular instrument is based on LIBOR. And here's a good rule of thumb. Whenever you've got an instrument based on LIBOR, you mustn't use compound interest in 365-day convention. With LIBOR, we want to use simple interest. And what does that mean? That means that if you have to deannualize your annual LIBOR, you take the LIBOR times n, which is the number of days over which the loan occurs, over 360. Please remember that. This is an exception to the other rules. The previous derivatives that we covered, so the zero coupon bond forward, the equity forward, the bond forward, all of those were using compound interest. This is the first one today that's going to be using the simple interest. So no compounding and 360-day convention. It's very easy to spot these ones because they occur on the instruments that use LIBOR as their underlying rate. We shall see more of those when we move to swaps, by the way. Okay, but let's get started with the pricing now. So here's a little example, okay. Yeah, by the way, we need to talk also about some unusual notation perhaps that occurs in forward rate agreements. So what is meant by 2 by 3 forward rate agreements? So contrary to what you might think, it's not equal to 6. It's not equal to 6. What this is it's basically telling me, the first number is telling me when the contract expires. So I know this contract will expire 2 months from today. So I'm going to sign a piece of paper. That piece of paper expires in 2 months. What is the second number telling me? The second number will tell me when that imaginary borrowing period will end. So I tend to abbreviate this as the end of the notional borrowing period. Okay, ENBP, end of the notional borrowing period. So in other words, yes, the instrument expires at time 2, but this is pretty much also the start of that imaginary borrowing, which then ends up at time 3, so that's the end of the borrowing period. So you can immediately spot that this borrowing period covers 1 month. Okay, so in a 2 by 3 FRA, the underlying imaginary borrowing period is a 30-day loan, 60 days from today. So what kind of party will be interested in this derivative product? Well, for example, I know that I'm going to be receiving some money 60 days from today, 2 months from today. Say I'm a company and I got a big receipt of money from a customer in 2 months. I'm worried that maybe rates could decline in 60 days, so I want to lock my rate via the use of a forward rate agreement. That's one possible scenario. So this picture will simply reiterate what we just said. In a 2 by 3 FRA, we start today, and the first number indicates the expiry, so the expiry is 2 months from today. The second number indicates the end of the notional borrowing period, and therefore the difference between the two numbers, 3 minus 2 is 1. That indicates that the underlying loan is a 30-day loan starting in 60 days. Excellent. Okay, now, of course, unfortunately, if we had to leave it at that, forward rate agreements won't be that too difficult, but we have to, unfortunately, also be responsible for pricing, which, by the way, was level 1 topic, so you should probably kind of know this. And then, of course, we've got the valuation, which is a level 2 topic, brand new level. Well, it's been in level 2 for a while, but you haven't seen it at level 1. Okay, so yeah, let's have a look at an example of that. Here's an example. Okay, example of pricing a forward rate agreement. I'm going to change the numbers a little bit to make it more exciting. So the numbers will be 1 by 3 in this time, 1 by 3. So the first thing I want you to think about together with me is, let's draw the timeline. So do you want to, while I'm speaking, start drawing that timeline and see if we guess it right, what that timeline will look like for a 1 by 3 FRA. I'll give you a few seconds there to think about what that is. So we're going to have a 0, okay, that's when we enter the contract. The first number will tell me the expiry of the product, so that expires at the end of 1 month. The second number tells me the end of the notional borrowing period. Okay, so let's again write that expiry, end of the notional borrowing period. So now you should also be able to tell me what the actual borrowing is. And well, the borrowing is a 2-month borrowing period starting at the end of month 1. Okay, So now the first thing that we need to know here is what is this forward rate. Remember, a spot rate is the rate at which I can lend today, lend or borrow today. A forward rate is the rate at which I can lend or borrow in the future. So I'm interested in what this forward rate is, right? What is this forward rate? And this is a level 1 topic. How do we discover that forward rate? Well, we need 2 spot rates. In this question, we've been given 3 spot rates, so there must be a red herring somewhere in there. And this is typical. You may be given more information that you barely need. And so don't just jump into answering the question and trying to make sure you use every single number that's in there. But first of all, draw your timeline and figure out what you're actually going to need here. Well, you're going to need the 1 month spot rate. So let's call that, I don't know what you want to call it. You can call it S1. And then you're also going to need the 3 month spot rate. Let's say S3. Okay? Because you can visually see, if you take S3, which is a long rate, and you subtract S1, which is a shorter rate, even on the picture you can see you'll be left with the missing piece of the puzzle. So in other words, I need the 1 month rate and I need the 3 month rate. The 2 month rate is a red herring and it doesn't actually get used in the question. Okay, so now let's proceed and price this forward. Okay, the first thing I want to say, and again this, especially for level 1 people, would be a little bit of a hurdle to jump through. I know probably level 2 people don't have an issue with this, but all rates in finance, very few exceptions, will be quoted on an annual basis. So when we said you could lend your money at 2.4% for 30 days, that doesn't actually mean you can make 2.4% in 30 days. That 2.4 is quoted on an annual basis. The very first thing you got to do is de-annualize. So remember the rule we said, simple interest with LIBOR, so take your LIBOR times n over 360, not 365. So because that's over 30 days, we apply this particular formula here. We get, what's that, 0.2%, that's in decimal. And of course we then proceed and we de-annualize the 90-day rate as 3% times 90 over 360. If you prefer, just divide it by 4. And this is 0.75% in percentage. So now what we're going to do is we're going to actually discover the fixed rate. Here's the formula that we follow. We take 1 plus the long rate, and what we mean by long here is literally the long arrow in the picture. So 1 plus the long arrow, which would be the 1 plus 0.75%, that will be in our denominator. We'll divide by 1 plus the short rate, which will be 1 plus spot 2%. We'll then subtract 1, and finally, because this will only give us a specific period, in this case that will be a 60-day loan, we'll have to then re-annualize that. So we quote your fixed rate on an annual basis. Okay, I know this sounds very conceptual, so let's actually jump into a concrete example of how this is going to be done. So if we animate all that, of course we've got the 30-day, this is now the annualized, got the 90-day, which is de-annualized. We're looking for the forward rate, which is missing. And we then apply this lovely formula where we take 1 plus the long over 1 plus the short minus 1. And because this gives us a 60-day result, we then essentially multiply by 6. Or if you prefer 360 over 60, same thing. And this now gives me the fixed rate of the forward rate agreement, the fixed leg of the forward rate agreement. And this is essentially what we mean by pricing a forward rate agreement. That's what we mean. Okay, now I know this formula may not look very pleasant to all of you. So here's one tip. You could use a common sense way to answer this, but it has to come with a big disclaimer. What I'm going to say next may or may not work. It's a linear approximation. It takes less time. You can just use common sense. You don't have to learn a formula, but it only gives you an approximate answer. So use with caution, namely, look at your three answers. If the answers are very spaced out, then go with the simple intuitive solution. The answers are very close and they kind of look like they're looking for a specific exact answer, then you're better off with the exact solution. But this is how you could do it intuitively. So intuitively, what you would basically say, now remember what we said if I go back to our original picture, right? We've got a long rate, S3, and we've got a shorter rate, S1. And basically, the intuitive answer is we need to take the long rate and subtract the short rate, and we'll then get our missing piece. And that's exactly what we will do. We'll use subtraction. So the long rate gives us 3%. Okay? You don't have to de-annualize that number. You don't have to decimalize that answer. Apologies. You can just stick it in as 3 in your calculator. Now, what we're going to do is this 3% is annualized, but it only refers to a period of 3 months, i.e. 90 days. So what we need to do is multiply by 3 over 12, right? Or 1/4 to de-annualize that number. We then have to subtract the 1 month spot rate, and we know the 1 month spot rate is 2.4%, and that was generated over 1 month. So we can de-annualize this with this lovely formula, 1 over 12. Now do this on your calculators real quick and tell me what you get. Are you joking? Can't hear you. So the answer is 0.55%. Okay. Now, is that the answer to a question? Well, of course it's not, because this 0.55% is only for 60 days. It's just for this period. We need to annualize that. So what we're going to do next is going to take the 55%, port 55%, and remember, what are we going to do here? If that's over 60 days, how do we annualize that? Multiply by 6. 6 times 60 is 360. And guess what we get? 3.3. Spot on. Now, but remember the disclaimer. We were lucky here. We got an answer that was close enough to the correct answer, but this will not necessarily always work. So use this simpler way with caution, please. Okay, moving on to the next idea. Okay, so when you valuing an FRA. Okay, so we're moving to the valuation basic. So that's it. We've priced it. I hope you enjoyed the pricing. It was anyway a level 1 topic, but now let's have a look at how we value these things. Okay, well, the original fixed rate was 3.3. And let's say rates have now increased to 4. Well, think about it. Long committed to pay a fixed rate. So long is going to win if rates have increased. So just conceptually, if you sort of understand how these products work, you should be able to eliminate potentially conceptually wrong answers. So if you've got an answer, for example, that says long pays, you don't care about what the number is because you know that's wrong. Long has to receive. So potentially you could get a 50% chance by understanding how the product works. Okay. And of course there is another big thing. This is going to be a little bit of a complication. These products pay in arrears. In other words, they don't pay at the end of the note borrowing period, they pay at expiry, which kind of complicates things a little bit, but we'll see this in practice. Don't panic. Okay, so we're continuing with our original 1/3 forward rate agreement example. Priced at 3.3, notional amount is 1 million, and we are now 10 days into the contract. So first thing that we're going to do, what do you think is the very first thing I would want to do at this point? Well, of course, I would draw a timeline. Okay, so I'm going to remind myself of the situation. 1/3 means that the expiry is on day 30. The end of the notional borrowing period is the end of month 3. And I am currently sitting on day 10. Okay, let's put a little guy here to indicate this is when we are valuing the product. Okay, so now what's going to happen? The first thing that I need to do, if you make a mental note of the process, the first thing you need to have in your mental note is you need to reprice the forward, which is kind of good news, isn't it? Because you just priced it. All you got to do now is reprice it. So repeat step 1 kind of thing. Redo what you just did previously. So how are we going to basically rediscover that forward rate on day 10? Well, again, I need to be given this spot rate, which is the 20-day spot rate between days 10 and 30, and I need to also be given the 80-day spot rate. Okay, well, let's check our original question. We've got the 20-day spot rate and 80-day spot rate, so conveniently we've been given exactly what we need in order to discover the new fixed rate. So these two numbers will give me the new fixed rate. Let's see how. Okay, step 1, de-annualize both of them. And again, I'm not going to be explaining this because it's essentially exactly what you did before. Just take the annual rate, multiply using simple interest by n over 360 to get the de-annualized rates. Then use this formula, 1 plus the long over 1 plus short minus 1, and of course finally you have to re-annualize. Okay, finally don't forget to re-annualize. So let's actually see this new fixed rate. Okay, there is a timeline here if you prefer as well, but I'm going to go straight to the solution. There you go. So that's the solution I'm interested in. So what I'm doing is I'm taking 1 plus the long rate, i.e. this rate, divided by 1 plus the short rate, i.e. this rate. I'm subtracting the 1, and because that's going to be a result for 60 days, I then multiply by 6, essentially, or 360 over 60 if you prefer. So that is the new fixed rate. Okay, so at this point you might say, well, what have you done so far? You've basically repeated the original exercise of pricing the forward. But how does this really help me get to the value of the contract on day 10? And to answer this, I want to draw yet another picture to show you what really is happening here. So if you remember, your original transaction was to receive LIBOR and pay 3.3% to, let's say, a counterparty, call it counterparty number 1. Okay, that was your original transaction. Now, 10 days into this contract, things have moved in your favor. You're making some modest profit, and maybe you want to exit the position. So how do we exit any position? Well, basically, if you've bought something, how do you exit? You sell it. So if you've gone long a forward rate agreement, how do you exit that? You go short. So you can do this with the same counterparty or different counterparty, or just go with a different counterparty. So the original transaction, A is long. Now A enters in a transaction with counterparty 2, where A will pay LIBOR and receive fixed rates. But now the fixed rate that they will receive at this point in time, day 10, is not going to be 3.3, it's going to be whatever we just computed. We computed 396. Okay, now notice what happens. Let's see if this is going to work. The LIBORs are meant, because they're the same thing, they're meant to cancel out. Right? There you go, brilliant, magic. And now we've got a guaranteed profit. Okay, it's guaranteed up to a point because, you know, counterparties can default and whatnot, but we've got a profit. And what's the profit? The profit is the difference between the new fixed rate and the old fixed rate. Now, of course, when you're punching this into your calculators, please use decimal format. Okay, I'm just using percentages here, but you need to press 0.0396, 0.033. These are annual numbers, so what's the next thing you gotta do? Bring them down to 60 days. So 60 over 360. Okay, so we need to create essentially a 60-day loan, or calculate the profit on a 60-day loan. And finally, remember, notional principle is there for us to compute the profits, so multiply by the $1 million. Okay, and hopefully if we perform this computation correctly, this should give us $1,100. Okay, and it's very, very possible at this point in an MCQ scenario, multiple choice, it's very, very possible for this to be one of the answers. And, you know, it's very tempting after having done, I should say, a lot of heavy work up to this point, it's very tempting to say, yeah, that could be the answer. Why not? I've done so much work, that should be the final answer. Unfortunately, it is not. Because essentially, this value is the payoff. At what point? Think about when that payoff occurs. This is the payoff right at the end of the timeline, on the original day 90 of the timeline. But by convention, these things get settled at expiry. So any cash will be exchanged at expiry. Even better, we are valuing this before expiry. So we need to bring that back all the way down to day 10 where the little guy was sitting. Okay, so we've got a picture that will show you that. Firstly, we computed the 1100, and that is right at the end of the timeline. See, that's exactly what we wrote earlier. But this is now the final key point. To get to the answer and score that important point, you now need to take the $1,100 and discount it back from day 90 to day 10, which is essentially 80-day period, at the 80-day LIBOR. Let's just check. The 80-day LIBOR was 3.6%. Just a couple of slides back. Go back and check. 3.6%. So we're discounting that back to day 10. Now don't get confused with this timeline here. In this timeline, we're using 0 as the valuation date. That's basically day 10 if you consider 0 to be the original date when we entered the contract. But the point is, this is where the little guy is sitting, and this is where we know we want to know the value. So the final answer to this question is 1,091.27. as the money that needs to be paid to loan. Okay, well guys, I hope you didn't find this too difficult. It is probably the kind of top of the mountain as far as forwards are concerned, and probably as far as other areas are concerned. So the good news is whatever remains should be nice and pleasant. Okay, but I would suggest re-listen to this another time, because this is probably one of the trickier areas. You want to get a little bit more exposure to it. Okay, pricing currency forwards. I'll start you straight away with the good news here. Not only are they easier, but you actually already know the formula from economics, because pricing currency forwards is essentially your covered interest rate parity, which you must know anyway fairly well from economics. So let's dive straight into the formula and revise that as well. Okay, CIRP from economics. What did it say? Well, it basically said that the forward price of a currency pair is determined by the spot price today and the inner relationship between the two nominal risk-free rates. So these are nominal risk-free rates. Now, one thing I want to clarify here is we do like the use of this notation, quoted and base, okay? Because this, I personally believe, is far, far better than thinking in terms of domestic versus foreign currency. If you think in terms of domestic and foreign, you can set yourself up for confusion. If you think in terms of quoted and base, the method is quite simply bulletproof. And let me just show you what we mean by quoted and base. So, for example, if I check the dollar pound exchange rate, and let's say I discover that it takes $1.55 to buy £1. Okay, so what's quoted here and what's base? Well, the first thing you want to do is put this into a ratio format. Essentially what you've got is $155 over £1. So the numerator is always your quoted number, and the denominator is always your base number. If you ever get confused, the base number is always the 1. Okay, the 1 is always the base number. So when I say quoted, I actually just mean numerator. When I say base, I just mean the denominator. So the very first thing we look at when dealing with any currency problem, as far as I'm concerned, I look at the pair. That's the first thing. Identify the quoted and the base correctly, move on and do the exercise. So let's have a look. So this is the pricing. Basically, this is simply covered interest rate parity. Now, in terms of the valuation, the formula does look a little bit daunting. But how can you get to this formula really easily if you already know your covered interest rate parity? So let me show you. So I know this formula, right? I know that the forward price is the spot price 1 plus RQ T over 1 plus RB T. Okay? Now essentially what I want to do is I want to divide both left and right hand side of this equation by 1 plus the quoted nominal rate. So what's going to happen? Well, if I divide the right hand side, let's start there because that's easy. If I divide the right hand side by 1 plus RQT, well, this item here will simply disappear, right? That's going to just go away. So I'm just going to have the spot divided by the base nominal rate. On the left hand side, I'm going to end up with 1 plus RQ to the power of T. Okay, that's the first step. The second step is simply to get this guy and move it to the other side. So essentially what we end up having is that the value of the contract is the spot discounted by the base rate, and then we subtract the forward discounted at the quoted rate. Now, don't get too panicky when you see all this notation, capital T, small t, capital T, small t. All this is saying is go back to your timeline, right? You entered the contract at time 0. Here's your valuation date. Let's call it small t. Here's the expiry of the contract. Call it capital T. So all we are saying here is that we need to discount for this amount of time between the valuation and the maturity of the contract. That's what we're doing. That's what we're doing. And of course, this will use the spot rate, the exchange rate at time t, whereas we will have the forward that was originally agreed at time t as well in this formula. So just to finish our notation, this will be the spot at valuation, this will be the forward at maturity. And there you have it, you got the formula. So if you thought this was hard to learn, well then be sure that I don't know that formula. I have not memorized that formula, and yet again in a couple of steps we can get there. Okay, almost there guys. I think we've got 1 or 2 slides remaining. Let's see what happens here. Credit risk in forward contracts. Okay, so remember, forward contracts are not necessarily mark to market. Yes, they do start with 0 value at initiation, but after initiation we've got potentially either negative or positive value. Okay, and this value can change dramatically. If we're not marking to market, we can build huge credit exposure to the party. Now, who actually has the credit risk? Is it the loser or is it the winner? Well, the loser needs to pay money, so they don't have credit risk. If the winner defaults, big deal. But the winner, the winning party, has all the credit risk because they stand to lose their profit if the counterparty defaults. Okay, so winners are particularly interested in calculating their credit exposure. And of course, to mitigate that credit risk, we often will require marking to market. We mentioned that earlier. Marking to market was the idea that we will pre-agree to periodically meet and make a payment from the losing party to the winning party. Essentially, we'll be able to reset the value of the contract back to 0. Okay, guys, I think brains are probably overheating by this point of the reading, but the good news is that we finished the reading, which is fantastic. It is an important topic. You probably do realize that this is one of the more technical areas. There are only 4 learning outcome statements, but obviously they cover quite a lot of material. We saw lots and lots of formulae. However, we also saw how if we thought of the formulae as conceptual processes, it was actually probably just 2 processes. One was pricing and one was valuing. And essentially all those derivative products did exactly the same thing when it came to the nitty-gritty. We did also demonstrate why those cost of carry formulae work. If we deviate from the theoretical no arbitrage price, then those clever arbitrageurs or arbors will step in straight away and exploit the mispricing via either cash and carry arbitrage or reverse cash and carry arbitrage. And so we did see lots of different products. We saw 0 coupon bonds, equities which pay dividends, then we saw bonds that pay dividends. We saw equity indices which were using continuously compounded dividend rates. Cosmetically, sure, the formula looked different, but they were doing exactly the same thing. So probably I'd argue the hardest thing we saw was the forward rate agreement. Pricing was a level 1 topic, worth revising again. Focus on valuing for level 2, because obviously that is your new kind of concept. And finally, we also saw how to price and value currency forwards, but the good news there was this was nothing but the covered interest rate parity. So guys, I hope this helped you and shed some light on one of the technical topics. All the best to your studies, and see you for some of the other readings. All the best. Bye-bye.